Hey there, I just wanted to finish our example that we had at the end of class today to give you one more example before you practice with these rational inequalities. And one of the big things to note that this one is already equal to 0, so we got to make sure that that's the case, and those will be kind of the extra step that we take today. But when it is equal to 0, we use our factors that will help us see what's actually being multiplied or divided in this case. So we have an x plus 9 in that factor and x minus 4 in here. So I can start to see based on these zeros, if I look to the left, to the right, and start plugging numbers in for my decision chart or my sign table, when I actually start dividing these, is it positive or negative for the outcome? So remember, we're going to put our zeros up top here. The smallest one is -9. The middle one looks like it's 1, and then this one is at 4. Then we put our factors that I'm going to just, they don't have to go in a specific order. Sorry, my tablet's changing colors randomly right now. They don't have to go in a specific order, but when you start calculating the positives, negatives, then you have to see where they are in that case. So we also have, we can do the x plus 9 here, and then the x plus, or x minus 4. So again, what we were testing yesterday is to see, okay, if the number is less than -9, when I plug it into this factor, is it positive or negative? So if I do -9, let's check -15, for example, just to be extreme. If I do -15 minus 1, that's going to be negative. If I do -15 plus 9, that's still going to be negative. -15 minus 4 is also going to be negative. Now I wrote it a little differently down here at the end just to show you like what we're actually calculating. So that x minus 1 becomes a negative divided by, it looks like a negative times a negative. Just to show you, okay, a negative divided by a positive, this full outcome then is negative. So we keep going, checking our range within here. For example, anything between -9 and 1, you can test. 0 might be an easy one because 0 minus 1 is negative. 0 plus 9 is positive. 0 minus 4 is negative. So then I'm having a negative divided by a positive times a negative, which that's a positive. Sorry, the calibration is a little off here, but negative divided by negative ends up being positive. Let's see if we'll switch colors here. Between 1 and 4, let's try 2, for example. If I did 2 minus 1, that's positive. 2 plus 9 is positive. 2 minus 4 is a negative. So then I have a positive divided by a positive times a negative, which in that case it ends up being negative. Then I'll go greater than 4, which in this case, if I do like 10 again, 10 minus 1 is 9, so that's positive. 19 is positive. 6 is positive, so any positive divided by all those positives is going to be positive as well. So then I start going to my interval notation because this bottom row here actually answers my question. I want to know when is the rational, this rational function here, greater than 0? Well, the regions where there's positives, that's going to be greater than 0. All those outputs are positive. I don't really care how high they go or low they go from there. It's just a matter of that they're positive. So if I'm talking interval notation, this symbol is really important as well. That it looks like between -9 and 1, it's going to be positive. I have a different region, so I'm going to have a union with another set of parentheses from 4 off into infinity. If I wanted to do this with inequality notation, I would say x, our little Beyonce, x is between -9 and 1, or is that big word or needed word that to have for inequality here to say x is then greater than 4. So looking ahead to some of the problems that you'll practice today, I just wanted to give you some hints before you start that. So that was part A there. Once you get into B, you know, fairly straightforward as a next step, but you got to factor that top, see what the factors are on the top and the bottom, and again, know if you're taking positives divided by negatives, negatives divided by positives. C, we have a rational minus a constant there. My hint or my first step would be get that into just one rational. So you're going to actually have to subtract this fraction minus that 5 to get one rational. Then it'll be the same as part A. D, Now, similarly, you got to get D to look like C. You have to get it equal to 0. So the hint would be subtracting 3, but then again, I got to combine those fractions to get to just one rational. And lastly, in 108 here, again, it looks like I have a quadratic, so I have the zeros, but they aren't the right zeros. I have to add that 7, get it equal to 0. B is just a little more complicated rational, but it's already equal to 0. Then similarly, we have the cubic, but it's equal to -4. And I have two rationals. Similar to the last part D, I can bring rationals over, get it equal to 0 first. Some things to watch out for when it's equal to. That might be a little bit different when we look at our sign table or decision table there. Like, does this number actually count? Is it an asymptote? So be careful there. If it's an asymptote, even if it says equal to, you got to be careful that that's not equal to. So at the end of class today, the answer key should open up, but I want you to try that with your group members first. And like I said, they'll open up at like 20 minutes left. Check those, check that you got the right symbols, interval notation, practice from there, and your signs tables. Good luck, and we'll see you soon.